All right, good morning. I'm going to plan on upsolving this question I missed from last week's contest, 2132 stamp in the grid. So I made a handful of mistakes that I learned from, and I just solved this one in Kotlin. So during the contest, I originally started with the top-down solution, which was a TLE. I quickly abandoned top-down since it's a fool's errand. It's pretty obvious we need to do some bottom-up pre-optimization or pre-calculations in order to reduce the asymptotic bounds to avoid TLE. So these other attempts that I did after the first one, all these wrong answers, these are all failures on a hidden test case I was trying to figure out. So I had two sessions. The first session was during the contest. I totally bombed it. The second session was on Wednesday, I think this was, and I made some progress. I finally understood what I was doing wrong, and then today I finally actually solved it. So anyhow, I was going to walk through a solution again in C++, and I'll just walk through and just describe my thought process. So hopefully it's helpful. So let me reset the code definition. Basically, this is what happened during the contest. I got the hidden failure. I didn't actually figure out why because I couldn't use deductive reasoning. But anyhow, let's just reset this over and let's start from scratch. So the basic strategy, I guess I don't need to go through all the failures, but I want to go through the success case. So the game plan in general here is to reduce the asymptotic bounds for stamping the grid. So via pre-calculations. This would basically be a two-dimensional prefix sum. So the first pass is to perform the calculations on A. So do prefix sums on A in order to say, okay, can answer this question. Basically, this is the question. Okay, so can I stamp the cell with top left corner IJ and bottom right corner UV? So here U would equal, let's see, for the stamp of size M in. So U would be I plus M minus 1, and we subtract 1 since U and V are inclusive of the range, something like that. So that's the first step, is prefix sums. So basically, whenever the prefix sums total is 0 for like this, then we can stamp the region I, J to UV. So then the next step is to take those prefix sums from this first calculation of prefix sums, and then, oh, actually, so here we'll mark a successfully stampable region via the bottom right corner UV. So this is arbitrary choice. We could also stamp IJ, right, the top left corner. It doesn't really matter. It's irrelevant choice. And the reason that's irrelevant is because basically during the second phase, we'll do prefix sums on the stamps from step 1. This is step 2. Up here is step 1. Okay, so step 1, step 2. So basically, the reason we want to do this is because we want to do O of 1 validations per cell. So basically, if we did not do the prefix sums, then it'd be O of m times n, which would be quadratic, which results in TLE, right? So basically do the stamps and then do the validations. So that's pretty much, right? So the TLDR, stamp A, then validate the stamps of A, right? Stamp A is okay, right? So that's the game plan. Okay, so let's code it. Let's see what happens. 917 is when I'll start. So this should be quite a bit easier because I've already done this before. Right? I mean, I just did it, so it's fresh in my mind. Okay. So here's our input matrix, and then M and N is the dimensions of the stamp. So capital M and N will be the dimensions of our input matrix. Oops. There. Okay, so the first function I'll create will be a lambda function that will be the actual prefix sums. Capture everything by reference. So actually, if we're going to do prefix sums, we want to just pass in the matrix by reference. And the reason is because we're going to pass in a couple different matrices. The first time would be prefix sums on the original input matrix A. The second time would be the prefix sums on the stamped matrix. Okay, VPI. So DP will be our dynamic programming matrix, which we'll build now via the prefix sums of A. So a lot of people will do the prefix sums starting the base cases at 0 and offset the DP matrix by 1, but I think that's super complicated. Since we're creating the recurrence relation, we get to choose where we want to put the base cases. And I'm going to choose to put the base cases at M and N because then I don't have to offset the DP matrix by 1. It makes coding it way easier. So let's just do that, right? So a little bit different, I guess a little bit more complicated would be the iterations of the for loops from I and J. So we'll iterate from the bottom right up to the top left instead of from the top left down to the bottom right. So it's a little bit weird, but this is a small price to pay for not having to offset the entire DP matrix. Oh, hold on, I don't need these things here. It's a simple calculation. The DP sub ij is equal to, so we're building it from the bottom right to the top left. So we're gonna have relative offsets in the positive direction. So it's A sub ij, which is the cell of the input matrix, plus I plus 1j. So that's basically the bottom plus DP sub I. J plus 1 is to the right. And then we subtract DP sub I plus 1, J plus 1, because that's the diagonal across. So basically that was added twice, once in here and once in here. So we want to subtract it once. So we do that once here. Okay. And then another thing that we'll want to do is have our prefix sum function, which will perform the calculations on our DP matrix in O of 1 time compared to a quadratic brute force solution. So what we'll do is we'll return, so building it from the bottom right to the top left. So the absolute difference will be subtracting the right and the bottom and the diagonal from the top left. So DP sub I sub J minus DP sub U plus 1 sub J minus DP sub I sub J. Oh, hold on. I sub V plus 1 plus DP sub U plus 1 V sub 1. So this is basically the same thing in opposite direction. So the prefix sum is basically we build it upon itself by including the matrix cell ij, the input matrix cell ij, and then we add on to it below and to the right, and then we subtract once below and to the right. So the opposite is that we'll subtract below, subtract to the right, and then add back once down to the right. Okay, so then the last step we need to do is the actual validation upon the stamped prefix sums. So return OK, stamp A. Hold on, we still need to stamp A too. So auto stamp. Okie dokie. Okay, so this is our original input matrix, and then S will be our prefix sums of the original matrix. And then what we'll do is we'll create T from S. So T will be our target stamp result. T, yeah, okay. So if you guys have N plus 1, return T, okay. So we want to do the same thing. We'll traverse the matrix from the bottom right up to the top left. Hold on, bear with me. Equal to J minus J, okay. Okay, so UV will be the bottom right of this thing. Make tuple. So U will be I plus M minus 1, and we subtract 1 to make I plus M minus 1. The endpoint U is basically inclusive. J plus N minus 1 for V. V is also inclusive. So if U is less than M, right, make sure it's in bounds, that we can actually place this stamp here. And the function of the prefix sums I, J, U, V is equal to 0, then we can place a stamp there. So we can place the stamp here. And again, this is arbitrary choice. Arbitrary choice. I'm pretty sure this will work okay by stamping IJ too. Right. We can try that out later on too. See what happens. Okay, so as long as the prefix sum comes out to 0, we can place a stamp there, stick it there in T. And then, yeah, okay, that looks good. The validation will basically go through each cell and do the same thing, right? Just make sure that there's one stamp that covers it. So auto S equals, want to do prefix sums on T for row of 1 lookups. Then, so, well, actually, yeah, the traversals, this traversal order I don't think matters either. This traversal order doesn't matter. Right, so we can either go from the top left to the bottom right, or the bottom right to the top left. It doesn't really matter, but being consistent, we might as well keep going from the bottom right to the top left, I suppose. We can test this later, right? Just try switching the order of the traversal here. So the order of the traversal only really matters for the original prefix sums. The other ones, we're just going to do a linear scan in either direction. It shouldn't matter. And same here, we can do a linear scan in either direction. It doesn't matter. For consistency, we'll go from the bottom right to the top left still, but we can play around with this later on and change it and see what happens. Okay, so bear with me. We'll type this in here. Okay, so here UV will be a little bit different. We want this to be pair. And we want it to be constrained though by the bounds. Like previously, we're trying to actually create stamps, so we have to make sure it's in bounds. But this one, we want to check the edge cases. And since we did the prefix sums, we want the edge cases to terminate at the bottom right corner at the very most. So here we'll do the minimum of I plus M minus 1. And the value that we want is M minus 1 at the very most. So then we can use the base case at M for that to build upon itself. Oops, this is J plus N minus 1, and that's constrained by the maximum of N minus 1. Okay, and then if a sub I sub j is 0, then we need a stamp. And if we don't have a stamp, then we're in trouble. F sub S I sub j u v. All right, so return false in that case. Otherwise, if everything looks good, we'll return true. Okay, so that's pretty much it. Is it okay to stamp A? And let's see what happens. M cannot be implicitly. Okay, we need a little equal sign there. Same for here, and same for here. So basically passing those constants by value. Getting it all. Semicolon there. No matching function for call to object of type lambda stamp. What's going on? Okay. Which takes in this. Candidate function expects an L value for the first argument. Oh, so it's R value. Okay. Well, we just pass it in like this. How about? Yeah, that works. Okay. So that looks legit. Let's see what happens. Boom. Okay, cool. So how long did that take? 9:17 to 9:28, about 11 minutes. Okay, so I am improving, so that's cool. Heading in the right direction. The first attempt, this one took me like an hour. I think the second attempt took me an hour. Third attempt took me an hour. Finally, this fourth attempt is in a reasonable amount of time, about 11 minutes. So that's cool. Let's try to get in Python. So again, I've tried this before. I failed. Didn't really work out so well, but we can give this a shot again. Might as well delete all this, clean up that. Okay, real quick, let's give this a shot again. 9:28 a.m. See how long it takes. Okay. Again, do this guy. So M and M capitalized are the indices bound, the bound indices of our input matrix A, and then lowercase m and m are stamp. Okay, actually, I'm going to go on mute because I've already pretty much described what I'm going to code, but I want to code a little bit faster and see if I can code faster. So hit this mute and then just jam.